Hello, this is Simple Math for you. Our lesson today is about proving triangles congruent using SSS SAS. أهلا بكم في قناتكم Simple Math for you، ودرسنا اليوم هو إثبات تطابق المثلثات باستخدام ثلاثة أضلاع أو ضلعين والزاوية بينهما. ضلع أو ضلع زاوية ضلع. Now, let's start by learning proving triangles congruent by SSS. Let's understand that SSS stands for side, side, side. What does that mean? In the previous lesson, we were proving that the triangle is congruent by proving that 6 corresponding parts are congruent. Means 3 angles in this triangle are congruent to the corresponding angles in that triangle, and also sides are congruent to their corresponding sides from the other side. 6 parts, 3 sides and 3 angles. In this lesson and the coming lesson, we will see that 3 parts will be enough, but we are not going to choose any 3 parts. There will be specific parts to prove that the triangles are congruent. What are these 3 parts? The first one, this first theory that we are going to use is SSS. It says that if 3 sides of one triangle are congruent to 3 sides of the second triangle, then the triangles are congruent. Let's check this proof. We have to prove that, and we will use kinds of proof. We have different setting of proofs. We can prove using flowchart as the one that we have here, or 2-column proof, statement and reason, or paragraph proving. Let's start by this one. Write a flow proof to show that the triangle QRT is congruent to triangle, the second one, SRT. So we try to find the given information that can help us. Let's read the given information. Read carefully. Triangle QRS is isosceles. Isosceles is the triangle that have 2 congruent sides, and he now specified what are the congruent sides that we have here. So let's put them on the sketch so that we understand. So he said QR is congruent to SR, and this is given. What did he do here? He copied this statement in the first box. Inside the box, you will write the statement. And under the box, you will write the reason. The reason is he has given us that this is an isosceles triangle. يعني هذا مثلث متساوي الساقين، وأعطي لنا أنه الضلع QR مساوي ومطابق للضلع SR. فهذا معطى، فكتبنا أنه هذا معطى. Okay, what's the second statement? The second statement states that RT bisects QS at point T. RT is this line or this ray actually. Bisects means cuts at the middle. منصف, cuts this segment at the middle. That means مباشرة we know directly that QT is congruent to TS. And this is the definition of the segment bisector. So here we will copy in the box the statement that is given, and it is given. The conclusion, so we will drag an arrow from that statement to state that QT is congruent to TS. And this is the conclusion. Why? What's the reason? This is the definition of segment bisector. So here, under the box will be the reason. Okay. Next, he is asking you to prove that the triangles are congruent. Now we have here 2 sides, as you see, are given to us. Do we need one more side? Yes, we do. We need one more side or one more angle. You will see that we will use that later. But we cannot find here any given side congruent to something. But as you see here, we have a side, which is this one, is common between the 2 triangles. It is part of the pink and part of the purple triangle as well. So that's why we will say that RT is congruent to itself, because it's RT here and RT there. In some even versions, they are saying RT is congruent to TR. Both are correct. And the property here is said to be reflexive property of congruence. Reflexive property means it's congruent to itself. And this is valid for all sides and angles as well. And then we will use these three reasons or three statements. This statement gives us the side. This statement gives us another side. This statement gives us another side. So the triangles are congruent by side, side, side. Three sides. We were able to prove that the sides are congruent, so the triangles are congruent. What if you were asked, مثلا, to prove that this angle is congruent to that? After you prove that the triangles are congruent, then as a conclusion, since everything is here is congruent to everything there, يبقى for sure angle Q is congruent to angle S, and this angle will be congruent to the corresponding, and this angle will be corresponding to that as what we call CPCTC, لأنه corresponding. It's called CPCTC, corresponding parts of congruent triangles are congruent. We have mentioned that in the previous video, I think. Let's check now this example. Triangle ABC has vertices mentioned, as you see here. Triangle EFG has another vertices. Is triangle ABC is congruent to triangle EFG? If it's not sketched, it's better to sketch them to plot the points as we have done here. Do we have any idea about any angle? No. The problem here is that we will not use protractor to measure the angle to check anything. So the only solution for us is to find the lengths of the sides. So we need to prove that AB is congruent to EF. BC is congruent to FG. AC is congruent to EG. Be careful with the order. So we need to find the length of the side. How can we find AB? B is this side. We know the vertices. A is 1, 1, and B is 0, 3. Remember that we used to find the length of the side if it is not vertical or horizontal by using distance formula. Distance formula states that we have x2 minus x1 all square plus y2 minus y1 all square. It's used to find the distance between 2 points in the coordinate plane or the length of the segment in the coordinate plane. So we can assume that this is x1, y1, and this is x2, y2, and let's apply. So x2 minus x1, يعني 1 minus 0 all square, plus y2 minus y1, 1 minus 3 all square. So it is 1 square plus negative 2 all square, which is 1 plus 4, which is square root of 5. So AB is the square root of 5. And you will repeat the procedure 5 more times to find BC, AC, EF, FG. And if you do so, you will find the following lengths. This will be 2 radical 2. This will be radical 17. This is radical 17. You can check alone and be careful with the calculation. Radical 5, and this is 3 radical 2. Now the question comes, are the triangles congruent? And this is the following question. Are the triangles congruent? If the triangle is congruent, as I said, then AB should be congruent to EF. Let's check AB. هذا أول واحد. AB, and this is EF, radical 17. So they are not, أصلا. AC should be congruent to EG, AC and EG. They are not. BC and FG. Sorry, AC and EG, AC and EG. Yes, they are not. So none of them is congruent يعني, to the corresponding one. Be careful. Don't see radical 17, so it's okay. No, or radical 5. We have to follow the order. So in this case, we will find that this will not be the correct one because this is not corresponding to that. We are not looking for those. The statement looks for another statement, another congruence. So we have to be careful that we should choose this statement because, again, BC is not congruent to FG. While here, he's saying AC, comparing AC with FG. It's not the right comparison. So choose carefully. This is the correct answer. Let's see this one. Is it easier? Can we find it using distance formula, or other way can be useful? Let's plot the points. A is -3 and 3. So this is A. B is -1 and 3. C is -3 and 1. As you see here, this is right triangle, right? Right triangle. It looks so. This is horizontal and this is vertical. In this case, it's easy to find AB by just counting number of units, which is 2. And also AC is 2. Just 1, 2. Now, BC can be found using distance formula or Pythagorean, if you remember. So we have here, this is 2 and this is 2. How much is this? You can say that it's the square root of 2 square plus 2 square, Pythagorean. So it's square root of 4 plus 4, which is square root of 8. So using the calculator, it is 2 radical 2. Okay, repeat the same procedure for the other triangle, which is KLM. K is 1 and 4. L is 3, 4. And we have M, 1, 6. It's also a right triangle, as you see here. And it's easy to find the sides. KL is 2 units. KM is 2 units. And as we have done for the first one, LM will be also same 2 radical 2 by Pythagorean. What do we found here? We have to prove that AB is congruent to KL. They are. BC is congruent to LM. They are. AC is congruent to KL. They are. So triangle ABC is congruent to triangle KLM by SSS. No need to check for angles because 3 sides now are enough. Let's go to something else. Now we need to prove triangles using SAS. And from the short form, we can say that this means side, and this is also side. Here it's an angle, but not any angle. It should be angle included angle. Included angle يعني between the sides. Let's check now. Here, this question. The kite shown appears to be made up of congruent triangles. If DE is congruent to FE, DE is congruent to FE or EF, same thing. EG bisects angle DEF, means EG cuts the angle into 2 congruent parts, تقطع الانجل إلى قسمين متساويين. Prove that triangle DEG, the one we have here, the triangle to the left, is congruent to triangle EGF, the triangle to the right. So we are looking for sides and angles if available here. What do we have here? First, here, this is called 2-column proof. And in 2-column proof, we have to write the statement and the reason in the other column. So the statement, the first statement here, you should start by the given information. So the given information is DE is congruent to FE, and this is given. Now, the second one is also given, EG bisects angle DF. I advise everyone to write all the given information at the beginning. And this is also given. It's not a conclusion done by me. What is the third statement? The third statement, we will use the benefit of the bisector. Why? Because we know that this bisector have cut this angle in such a way that this angle is congruent to that. And we need to prove some congruent angles. So that means we will write that angle DEG is congruent to angle from the second triangle FEG. And the reason will be definition of angle bisector. It's not given now. Now, so far we have one side, one angle from one of the triangles are congruent to one side, one angle in the second triangle. What's left? We need either another angle or another side. Where is the side? As you see here, this side, the one at common between two triangles مشترك بينهما, and that is EG. So we will write EG is congruent to itself. We can write GE or EG نفسها. And this is reflexive property of congruence. Of congruence, yes. E is not appearing. Okay. So we have now side, then angle, then another side. And as you see here, side, then angle, then side. This is side, angle, side, side, angle, side. The angle is between them, not any angle. Yani if you are talking about this angle, this is not beneficial for us. So the theory we have used is side, angle, side. Done. Now we will write two-column proof. So we will put here a statement and reason. Two-column proof. AB is congruent to XY. AB is congruent to XY given AC is congruent to XZ, also given BC is congruent to YZ, given. We have listed all the given information here. Now everything is easy, everything is mentioned. We have the three sides are ready for us. So that means what? We were able to prove that the triangles are congruent, so the triangles needed A, B, C is congruent to triangle X, Y, Z by side, side, side. Done. Next, two-column proof here for this one. So again, we will write statement and reason. We know now AB is congruent to CD, and I will write it. It's CB by mistake, by the way. CB. And this is given. D is the midpoint, نقطة المنتصف of AC. So that means directly we know بينها بالنص, then this is equal to that. So I will write the statement إنه D is the midpoint because it's given. And the benefit of that, or the conclusion إنه شو؟ إنه AD is congruent to DC. This is due to the definition of the midpoint. So we have here side. Where is the third side? The third side is this one. As we have learned, it is common between the two triangles. 3. So 4, we have side DB is congruent to itself, and this is a reflexive property of congruence. That means we have reached the conclusion needed that triangle ABD is congruent to triangle CBD by side, side, side. Done. We have proved now that triangles are congruent by SSS. Third one, also we will need to write two-column proof. Statement, reason. Given AB is CD is shown equal to that one. So AB is equal to CD. Given. According to that, because AB is equal to CD, فأكيد AB will be congruent to CD, because since they are equal in measure, then they are congruent. So this is the definition of congruence. Given also that EB is parallel to CD, this is given, we will use it. How do we use it? Since this line is parallel to that, then we have alternate interior angle as you see. So angle BAD is congruent to angle CDA. The reason? Alternate interior angles. So we have now side and angle. We need one more side. As you see, AD is common between them, so it's congruent to itself, and we will say reflexive property of congruence. Did we reach the conclusion? Of course, yes, it's enough now. So triangle ACD is congruent to triangle DBA, and the reason will be side, angle, side. We have side and angle and then side. We will continue with the real life application. And now we have an exercise about gaming. Devontae is building a house in a simulation video game. He wants the roof of the house and the main support beam to create congruent triangles. Congruent triangles. So we need ABC, triangle ABC, to be congruent to triangle BDC. This is what we need now. So we will start to use the given information here. If BD is perpendicular to AC and BD bisects AC, perpendicular and bisecting AC, we are going to copy this statement here, and this is given. We are not concluding anything. It's not a conclusion from us. It was given before. Then, what is the conclusion? If you know that BD is perpendicular to DC, or perpendicular to AC, I mean the whole one, that means a right angle will be formed. That means here we will know that the angles BDA and BDC are right angles. And he said that. What is the reason? That perpendicular lines form right angles, short form. إذا لأنهم متعامدان الزوايا قائمة. سبب إنه كتبنا إنه الزوايا قائمة فهما متعامدان. طيب بما إنه الزوايا قائمة, since this angle is right and this angle is right, that means the angles are congruent. That's why here in statement 3 mentioned that angle BDA is congruent to angle BDC, and the reason will be all right angles are congruent. This is, of course, common sense, because all right angles have a measure of 90 degrees. What else we need? Now we have here used the perpendicular. We didn't use the bisection. Bisect. BD bisect. Bisect means cut at the middle. That means this part will be equal in length to that one. That means we can say that AD is congruent to DC, and that is due to definition of segment bisector. من خواص المنصف إنه يقسم لك القطعة إلى قسمين متساويين. إحنا we need to prove as much as we can. So we have this segment, and now we have a right angle. What else? Now we have here this common side. So we will mention that BD is congruent to itself, and you should remember the property is reflexive property of congruence. Property of congruence. Last statement, then we have here side, and then we have an angle, and then we have another side here. That means that triangles are congruent by side, angle, side. This is the proof that we are looking for. Let's move on now. Explain whether there is enough information given in each figure to prove that the triangles are congruent using SSS in 3 sides, or side, angle, side, 2 sides, and angle included. Let's check question 1 here. What is given? We have here this side is congruent to this side. We have this side is congruent to this side. Now we have 2 sides. Is there another side given? No. Is there any angle given directly? No. But everyone knows that this angle is congruent to that because they are vertical angles. متطابقين زاوية متقابلة بالرأس. فصار عندنا side and then angle and then side in order. Side, angle, side. So yes, by side angle side. Next, here we have only given this side is congruent to that. And this is due to the first triangle, in the first triangle, and this is in the second triangle. So we have one side. Also, we have common side, which is this one. This is common. You do reflexive property. QS is common. Okay, we have two sides, but we have nothing more. We have no extra information. One may tell me, Miss, this is alternative interior angle. Alternate interior angle. I mean, yes, they are, but we cannot say that they are congruent because here we did not know that the lines are parallel. So here information is not enough. Okay, let's move on here. We have here in this triangle ABC, we have this angle is congruent to that. We have another side congruent to this one, side and angle, and everyone knows that it is common here. So we have here side, angle, side, side, then angle, then side. For this question, we have only two angles given. This side is not totally common between the two triangles, so we cannot say that the triangles are congruent and the information is not enough. Here, determine which pair of triangles cannot be proved congruent using the SSS or SAS postulate. Let's say here we can say that this side is congruent to that. We can say that this angle is congruent to that one due to the vertical angle theorem, but nothing more was mentioned. So here we cannot prove. So we can't here. We can't prove that. Information is not enough. Not enough information. We have to have one more angle or one more side. Let's see this one. We can see that this side is congruent to that. We can see that this side is congruent to that. And we can see that this side is common. That means we have three sides. So yes, here we can prove it by side, side, side. For this triangle, we have a side, we have another side, we have an angle. And actually, until this moment, we cannot say that the triangles are congruent unless you know that this is common side. So you can say that there is a side, then angle coming in order, then another side. So yes, using side, angle, side. Because if you mention only this side and this angle and this side, it becomes side, side, angle. There is nothing called side, side, angle. So in this case, we were able to prove that well, the first one only cannot be proved congruent using SSS or SAS postulate. With that, we are done with this lesson. Thank you for watching. See you. إلى اللقاء.